Good afternoon. I'm Angelo Raimundo, and I will be presenting my project for ECEA101-1L. So the project that we were supposed to do is called the Mosfet or MOSFET amplifier circuit. Stands for metal oxide semiconductor field effect transistor. So let's move on and look at the design. Um, so if we were to explain this design, we can see that there are two voltage sources, four resistors, and two capacitors, five resistors, and one um, MOSFET resistor or MOSFET transistor rather. Um, so for the voltage sources, it uses for the voltage one, it uses 5 DC value, 5 volts, and the voltage 2 uses a sine function. So for the capacitors, it uses 1 micro and 10 micro. For the resistors, it uses 100k ohms, 42k ohms, 100 ohms, 20 ohms, and 10k ohms. So for the MOSFET or MOSFET transistors, we are going to use an IRL ML6436346 transistor, which is manufactured by International Rectifier. So let's move on and let's discuss the advantages and disadvantages. So for the advantages of the MOSFET is that this design can scale down in size, so it is entirely different with other designs. It also has low power consumptions, and the MOSFET transistor is very easy or well, easy to manufacture. So for the disadvantages of this design, the MOSFET has a short life, and it is also very susceptible to overload voltage, which can lead to minor explosions or burning of the circuits. So it requires an expert for installation. So let's move on. Let's move on to the power, bandwidth, and amplification factor. So we will be discussing it, how we got the power, the bandwidth, and the amplification factor. But here are um, the numbers that I was able to get in getting the power, bandwidth, and amplification factor. So for power, I got 0.23, the bandwidth is 0.12, and the amplification factor is negative 1.00. So the simulation results looks like this. Um, the red markers or the red wave is the V in, and the V out or the green is the V out. So the blue markers is the current or the input current, and um, the light green is or the light blue is pretty much the gate gate current that is from the MOSFET from the transistor. Uh, if I can explain again the design, the MOSFET is pretty much, well, it's not really that different with the BJT, but the MOSFET is pretty much, it's almost the same, but it has a different configuration because the BJT uses the emitter and collector sections, but the MOSFET uses gate, source, and drain. So for the emitter and collector, these two sections emits and collects, right? It's as simple as that. But for the MOSFET, the the these terminals, source, gate, and drain, um, FET controls the flow of the current by the application of a voltage to the gate, which in turn inhibits the conductivity between the drain and source. So they're known as unipolar transistors. So let's move on to the demonstration. Yeah, we are to wait. I'm just gonna set it up. There we go. As you can see, this is the design of um, the Mosfet amplifier circuit. So I have already done the um, the the operations for the circuit. So if we are to explain it, well, the OP is just for the operation and the transient is just for the waveforms. If we are to show the waveforms again, then sure, we can do it again by doing this. First, let's add a plot pin. Then let's add V in. Let's add V out. Let's add the IC1, and then let's add the drain, just for the sake that it is for both the output. Um, so this is the look for the waveforms that is made in this MOSFET amplifier circuit. So for the project, let us solve it again in doing this. So for the first part, we are to solve the peak to peak of the G in and the V out. So we are going to, I'm going to explain it. So first, the measure or that mass transient VI peak to peak V in. So that solves uh, the V in peak to peak, as well as for the V out peak to peak. It is almost the same. If we are to solve the average voltage, then we are to do the parameter for V out peak to peak and divided by VI peak to peak. If we are to look at the current for the input peak to peak, then we are to look at the IC1. For the I out peak to peak, then we are to use the I or the current for the drain that is from the MOSFET transistor. Then we are to, if we are to look the average of the current, then we are to use the two name calls or the variables that will be used, which means we are to divide the current output by current input. If we are to get the power, and we are to multiply the average current with the average voltage. So next one, when we are done with the power, then we are going to with the bandwidth. So when you are trying to find the bandwidth, then you need then you need the frequency. So let's look at the frequency. So we are to find T1, and we need to put it in a 50. As the instructor said, if we are to choose the value, we need to put it on the middle, or just choose any value as long as it is from the middle towards the top. So what I chose is 180 for the output and 50 for the input. And as you can see, 50 and 180, which is both on the range. So the frequency for the input, 1 divided by T2 minus T1, and for the frequency output, 1 divided by TB minus TA. And if we are to find the bandwidth, then the parameter is frequency input minus frequency out. And if we are to look for the um, amplification factor, we are to use ID or I drain divided by I source, and that is that for the demonstration. Thank you and God bless.